Okay guys, in this lesson, we're going to learn how to write a quadratic equation given certain data points. We have learned that there are three different ways we can write a quadratic equation. We have standard form, where we easily know the y-intercept, which will be when x is 0. We also know factored form or intercept form, where we know the x-intercepts, p and q. And we also know vertex form, where we know the vertex of the parabola, h and k. So it depends on what you have been given is which form to use. But before we move forward, let's take a look at three function tables. Each of these tables is either linear, exponential, or quadratic. We have learned how to identify a linear function table because it has a constant rate of change. We can easily identify exponential function because we have a common ratio. We are multiplying a common ratio to get from output to output. And for a quadratic function table, it will possess what's called a second difference. So let's get started. First of all, notice that each of these function tables has consecutive x values. -4, -3, -2, -1, 0, and so forth. Now let's look at the output. How are we getting from 29 to 19 to 11 to 5 to 1? From 29 to 19, we see that there is a difference of -10. From 19 to 11, we can see there is a difference of -8. From 11 to 5, we are going down 6, and from 5 to 1, we're going down 4. We can see there's not a constant rate of change. We are not multiplying by a common ratio, so this is neither linear nor exponential. So after we find the first difference, the difference between each output, let's see if there is a second difference. The difference between -10 and -8 is going up 2, from -8 to -6 is going up 2, and from -6 to -4 is +2. So when we have a second difference that is the same, this tells us that this is a quadratic function table. Now this second difference will help us find the a value of our equation. So the a value is the second difference divided by 2. So for a quadratic function, our a value is going to be the second difference divided by 2. So in this case, we have 2, which is our second difference, divided by 2. So our a value is 1. This will be helpful when we're learning how to write our quadratic equations. So our first table is quadratic. Let's look at our second table. We're going from -24 to -21, so that's going up 3. -21 to -18 is up 3. -18 to -15, +3. And our last one from -15 to -12 is +3. And like we said, our output values are consecutive, so they're all +1. So this tells us this is a linear function. And our pattern, our constant rate of change, 3/1, is our m value of our equation. So our m value is 3, or 3/1. Let's take a look at our last table. We're going from 32 to 16 to 8 to 4 to 2. So I can kind of just see the pattern that this is being divided by 2. Or in other words, we could say it's 16/32, 8 over 16. We could compare 4 to 8 and 2 to 4. And if we simplify these, we see a common ratio of 1 over 2. So this tells us that this is an exponential function table. And our b value is the common ratio of 1/2. So you can see our function tables gives us a part of our equation for any of these functions. So let's focus and let's learn to write our quadratic function. But before we do that, let's just recall how to write a linear function and exponential before we do our quadratic function. So again, we notice in our linear table, our x values are increasing by 1. They're all consecutive. Now let's compare the output. We can see we are going down by 3 from output to output. Therefore, our constant rate of change, our m, is -3 over 1, or -3. So the m value is 3. We do not know our b value, our y-intercept. That would be when x is 0. We do not have that ordered pair. So let's just pick any ordered pair from the function table to be the x and f of x in our equation. So I'm going to replace f of x with -17. Our m is -3. Our x value, when our output was -17, is +3 and plus b. We're going to multiply -3 times 3. That gives us -9. And now we're simply solving for b. We're going to add 9 to both sides. And the b value is going to be -8. We can put this all together and we have y equals slope of -3 times x minus 8. Now let's write the equation for our exponential function. We see that the pattern is we are multiplying by 2. The way we see that officially is compare an output to the previous output. And it is obvious that this common ratio is 2, but sometimes it's not so obvious. So make sure that you remember to compare one output to the previous output. And again, our x values are consecutive. So this common ratio tells me that the b value is 2. So we're going to replace b with 2. We do not know our a value, our initial value. So we're going to pick a point, any point from the table, to be our x and f of x. So let's replace f of x with 2 from our table here, equals, we don't know the a value. The b value is also 2, we just found. And our input value, when our output is 2, is 3. Now we're going to solve for a. 2 to the 3rd is 8. So we have 8a. We're going to divide each side by 8. And the a value is 1/4. So our equation is f of x equals 1/4, the a value, times our multiplier of 2 raised to the x. Now our last table is quadratic. We are going to find the a value. The a value is going to be the second difference divided by 2. -6 to 1 is going up by 7. From 1 to 14 is +13. From 14 to 33, that's going to be 19. And from 33 to 58 is going to be 25. So this is called the first difference. Now let's find the difference between the first differences, and this will be the second difference. So from the difference between 7 and 13 is +6. 13 to 19 is +6. and 19 to 25 is plus 6. So when our second difference is the same value, we know this is quadratic. So this is called the second difference. So our A value is going to be 6 divided by 2 is 3. So A is 3. Our C value also has to be given to us. It's -6 because it is our y-intercept. So the value we don't know is the B value. Let's go over this. We're going to plug in 3 for A. We just found that with our second difference. We're going to plug in -6 for C. We got that from the table. And then we're going to pick a point other than the y-intercept to plug in for our x values and our f of x. I'm just going to plug in 2, 14. So 14 is f of x. Our a value is 3. The x value is going to be 2 from right here. So everywhere we see an x, we're going to put 2. We do not know the b value. And our c value is -6. We're going to square the 2. That's 4 times 3 is 12. Plus b times 2 is 2b minus 6. Combine our like terms. I have 2b plus 6. 12 minus 6 is 6. Solve for b. Our b value is 4. So let's write the function. F of x equals our a value of 3, x squared. Our b value is 4. 4 times x minus 6. So here is our quadratic function written in standard form.